Why do amplifiers oscillate, and how can it be prevented? Imagine turning on your audio system and suddenly hearing a high-pitched squeal or a loud hum. That's often caused by an amplifier oscillating. It might seem like a small glitch, but it can seriously affect your device's performance. So, why do amplifiers sometimes start to oscillate, and what can we do to stop it? Let's find out. Oscillation in amplifiers happens when the output signal loops back into the input in a way that sustains itself. This feedback loop can happen naturally if the circuit isn't designed carefully. When the feedback is in the right phase and the gain is high enough, it creates a continuous cycle of signals. This is more common at higher frequencies, where tiny parasitic effects can cause phase shifts. Parasitic components are unwanted stray capacitances or inductances that sneak into the circuit and change how signals behave. These tiny effects can introduce extra poles or zeros in the transfer function, making the amplifier unstable. High-gain amplifiers are more prone to oscillate because they amplify even the smallest feedback signals. As the frequency increases, the phase shift in the feedback loop becomes more significant, pushing the circuit toward instability. This can cause unwanted noise, distortion, or even damage to the device. To prevent oscillations, engineers focus on creating a stable design. One key method is ensuring there is enough phase margin. This means designing the amplifier so that the total phase shift around the feedback loop stays below 360 degrees at the point where the gain is 1. Adding a small resistor in series with the load capacitance can also help. This resistor reduces the phase shift caused by capacitive loads, making the circuit more stable. Good layout practices are essential too. Keeping sensitive parts close together minimizes parasitic effects. Using proper shielding reduces electromagnetic interference that can trigger oscillations. During the design phase, analyzing the open-loop gain and phase response helps identify potential stability issues before building the actual circuit. In real-world applications, preventing oscillations is vital. For example, in audio systems, oscillations can cause annoying noise or distortion. In radio frequency amplifiers, they can interfere with signals and reduce efficiency. By understanding what causes these oscillations and applying proper design techniques, engineers can create amplifiers that work reliably and produce clear signals every time.